Hello everyone, welcome to Code Compass. Today we are going to be solving second problem from top interview 150 problem list from Leetcode. Let's jump directly to the problem and go to the problem statement first. So it says, given an integer array nums and an integer value, remove all the occurrences of value in nums in place. The order of the elements may be changed, then return the number of elements in nums which are not equal to value. So basically they have given us an array and they have given us a value, and they want us to remove all the occurrences of that particular value from inside the array. So let's go further. Consider the number of elements in nums which are not equal to the given value bk. To get accepted, you need to do the following things. Change the array nums such that first k elements of nums contain the element which are not equal to the value, and the remaining elements of nums are not important, as well as the size of the nums, and they want us to return k. So basically what they want us to do, this will become more clear with an example. So let's go to the example to understand it better. So they have given us one array which is 3 2 2 3, and they have given us a value which is 3. So what they want us to do, first of all, they want you to remove all the occurrences of 3, which is basically this 3 and this 3, and shift all of those values which are not equal to 3 to the starting of the array. So basically this 2 and this 2, they come to the starting of the array. Rest of the elements they have shown as underscores because they don't really care about those values. You could put junk value, you could put like anything whatsoever. They don't care about the rest of the values. They just care that the starting elements should be all non-matching elements if compared to value. And in the return type, they want you to return 2, which is how many elements are there which are not equal to 3. So there were 2 elements, first 2 and second 2. So we are expected to return 2 over here. So problem statement is pretty clear. Let's go to the go through the second example as well. So here we have 0 1 2 2 3 0 4 2, and value is given as 2. So now what we would be expected to do, remove all of those elements which are equal to 2 and basically bring all other elements to the starting of the array, so which is 0 1 4 0 3. And now notice they don't really care about order of these values either, like because in the original array 4 is appearing after 3, but in the output 4 is appearing before 3. So they don't really care as long as you are moving all the values, all of those elements which which are not equal to 2 to the front, and returning the correct number, which is 5. So 5 here means there are 5 elements 0 1 4 0 3 which are not equal to 2. That is what they want you to return. So I hope the problem statement is clear. Let's go to the intuition of this problem. Alright, so to understand the intuition behind this problem, first let's forget about the fact where we have to do everything in place. Let's just think about how we would have done it if there was no restriction of doing it in place or whatever. So let's say they gave us this input. I have taken the same input which was given in the example, 0 1 2 2 3 0 4 2, and value was given as 2. So let's say that I asked you remove all of those elements which are not equal to 2. So what would you do? Like, you will start iterating from the beginning. You will check that okay, 0 is not equal to 2. You will put it in the result set. Let's call it as result set. We will come to how we will do it as per the requirement of the question, but let's just try to build the intuition first. So 0 is not equal to 2. We place 0 over here. Then 1 is again not equal to 2. We put 1. Then 2 is equal to 2. So we skip it. Then we go to 2. We skip it. Then we go to 3. 3 is not equal to 2. We put it over here. Then we go to 0. 0 is not equal to 2. So we put it in the result set. Then we go to 4. 4 again is not equal to 2. So we put it in the result set. Then we go to 2. 2 is again equal to 2. So we don't put it in the result set. So that's it. So basically we are just doing comparison one by one, and as soon as we see an element which is not equal to value, we put it in the result set. This is exactly what we have to do in our overall solution also, with just one minor modification, that all of this modification has to be done inside this array itself. We don't have an additional array, and we just have to modify the existing array. So let's see how we will do it in the existing array itself. Okay, So now let's come back to the original problem. I've again taken the same example 0, 1, 2, 2, 3, 0, 4, 2. So let's say I define a variable NMI. NMI basically means non-matching index, and non-matching index basically denotes the where the next value which is not equal to the given value, which is 2 in this case, should be placed. So hear it again. It denotes that index where the next possible value from this array which is not equal to 2 has to be placed. So we initialize it with 0 from the beginning. Now the intuition is very simple. You start iterating, you create a pointer I. At every step what we are going to do is, if an element is not equal to the value, so what we did in the original example, if the current value is not equal to the value which is given, which we have to compare against, we will put it in the result set. So what we do is we will simply set it at the next index which is being tracked by NMI, and then we will increment this, otherwise do nothing. So as simple as that. So let's do a dry run, then things will become more clear. Okay, so let's start. I have put written the indices value also 0, 1, 2, 3, 4, 5, 6, 7. So let's see what happens when I is equal to 0, and NMI also is initialized with 0. So at I is equal to 0, 0 is not equal to 2. So what we do, we update NMI's value with array of I, which was 0 itself. Then what happens, both of these get incremented. So now this points over here, I also gets incremented. So now array of I is 1, 1 is not equal to 2. So we simply update this index again. So right now it looks like we are just overwriting the values, but things will become more clear as soon as we encounter a value which is equal to this target. And then both of these get incremented. NMI comes here, I also comes here. Now array of I is equal to 2, and in this case we don't need to do anything, simply increment I. So let's just do that. Now here you see the difference. So NMI is still at index 2. So as per our logic, if we ever see a value which is not equal to 2, it has to be placed at index 2. This is important. And then now at array of I is again equal to 2. This is the same, we don't need to do anything. So what we will do, we will just simply increment it to the next possible index, which is 3. Now 3 is not equal to 2. Now what we are going to do, we update this value with 3, and then this also gets incremented, and I also gets incremented. So now NMI will point to this index and I will start pointing to 0 index. So now you see the array is slowly starting to have all those elements which are not equal to value in the beginning of the array. Now again same logic, array of I is 0, 0 is not equal to 2. So what we will do, we will simply update the value of this index with 0. Simple as that. And whenever we do this, we will increment both NMI. Now it becomes over here, I now comes to 4. Now again do the same calculation. So 4 is not equal to 2, which means I need to update 4 over here. So this becomes 4, and now we will increment both. Now it comes over here, and I will come to 2. Now this is the last comparison. So now 2 is equal to 2, so we don't do anything. So NMI will remain over here only, I will go outside the array, and our iteration will stop. And now what happens is, if you look closely, NMI's value is now 5. And how many elements were there which were not equal to 2? 0, 1, 3, 0, 4, which is also 5. So basically at the end of this iteration, NMI will hold the value which will denote how many elements which were not equal to value, and we simply will return this at the end. That's it. So this is the intuition. Let's see how it will look like in the code. Okay, so let's get started with the code. Then the intuition will become even more clear, and let's try to implement it over here. So first of all, let me initialize NMI. I will simply call it as NMI as 0, and in the end I will simply return it, because that will hold how many elements were there which were not equal to value. So what we are going to do, let's iterate the array one by one, and at each step we just need to check what if array of I is not equal to value, then we need to update the array, otherwise we don't do anything. So let's just write exactly that. So if nums of I is not equal to the value, then this means I have encountered a number which is not equal to value, so it needs to be shifted to the front of the array. So let's just simply do that. Nums of NMI non-matching index is equal to nums of I, and for the next iteration let's update NMI. As simple as that. If they don't match, we will not do anything, and in that case I will get incremented, but non-matching index will not get incremented. Denotes where the next non-matching value should be placed. So essentially what we have done, we have shifted all the elements to the front, maintaining their order, although the problem does not require us to do so, but we have maintained the order also. So let's try to test it and then submit it. Okay, it's running. Yeah, so as we can see, the base test cases are passing. For 3223 our output is 2,2, and the expected output is also 2,2. For case number 2, the expected output is 01304, but we have returned 01403. As they stated in the problem, they don't care about the order of the elements, so our scenario is also perfectly valid. So now let's submit it and see if all the test cases pass. Perfect. So now all the test cases are also passing. So I hope you enjoyed the explanation and you were able to understand it, and see you in the next one.